Hello, everyone. Today we're talking about section 3.6, negations of conditional statements. And so a negation of a conditional statement, the parentheses there, the P implies Q is a conditional statement. The negation of that would just have a not out in front of it. And so really this is just a continuation of section 3.5. I'm not sure, well, we're not going to go into the depths of 3.6 here with homework and so on. And so I'm just doing kind of the first part of 3.6 with you. And really, it just kind of completes everything we talked about in 3.5. And so, let's look at that. So suppose your accountant or your tax person makes this statement. If you itemize deductions, then you pay less in taxes. That would generally be true. I want my children to get to the point where they can itemize their deductions. Of course, the tax rules are changing here, but to where they can get to where they are paying less taxes, to itemizing things like your mortgage payment and your charitable contributions and things like that. So if that's our original statement, we want to determine when this would be false, because we're talking about negating a conditional statement. So when this would be false is, or in other words, the only case where you would have been lied to by your accountant here, is if you do itemize your deductions and you do not pay less in taxes. That would make this a false statement or a lie. Okay, so let's break down our statement here. The hypothesis of the statement is you itemize your deductions. Okay, we need to be a little bit careful here with our Q. You pay less in taxes is what we're actually looking at here. Okay, and so you pay less in taxes is our conclusion. And so if we put it in a conditional statement, as we did, if you itemize deductions, then you pay less in taxes. So that's our original statement. We just wanted to break it up into the P and Q hypothesis and conclusion parts. Okay? And then we want to compare it to this. Actually, this is our and statement of the negation, basically. The part up there where I put where the lie would be. The lie would be if you itemize your deductions and you do not pay less in taxes. So notice how the English of that is, and we want to translate that symbolically. And so if you do itemize your deductions, that's our P, right? So there's the P, and, so there's our and symbol. You do not pay less in taxes, and so there's our not Q. So that English statement of the lie translates symbolically into P and not Q. You itemize deductions and you do not pay less in taxes. Okay? So basically the symbolism here is that the P implies Q, the conditional statement, is negated or is false when it is P and not Q. That's really what we're trying to get to here. Okay? Those are negations of each other. So here I'm kind of stating it again. There's our original conditional statement. If you itemize deductions and you pay less in taxes. Here is our and not, and so the lie, the time it's false. You itemize deductions and you do not pay less in taxes. Okay? So let's look at the truth table of that. P implies Q from our conditional statement truth table back, I think, in section 2. The P implies Q is true, false, true, true. The only time a conditional statement is false is when P is true and Q is false. Okay? If we do the truth table for P and not Q, which we looked at in the last section at the beginning of section 3.5, then that truth table is false, true, false, false. Or in other words, it is the exact opposite of the conditional statement P implies Q. And so therefore, again, we're just showing you in a truth table, therefore those two statements at the top are negations of each other. Okay? P and not Q is the negation of P implies Q. Okay? So there is the definition of this. The negation of a conditional statement, again, a conditional statement is just P implies Q. The negation of that is P and not Q. And symbolically, all of that can be written as the negation of P implies Q is equivalent to, now again, remember those 3 lines for an equal sign is equivalent to P and not Q. That's the definition of that. Okay? So pretty much what we can do now in this section is summarize really what we talked about in 3.5, again in this first part of 3.6. And so we can put everything that we know about conditional statements in one box here. So we have the original conditional statement, P implies Q. If P, then Q. We talked about the contrapositive in section 3.5. We talked about the contrapositive is the equivalent of that in terms of truth table. So P implies Q is equivalent to not Q implies not P. That is the contrapositive. So the conditional and the contrapositive are equivalent. Okay. We learned in the last section that converse and inverse, the converse is, if the original statement is P implies Q, the converse is just switch the order. Q implies P, and that is not equivalent. That is not necessarily true. Okay. And so it's not necessarily true, it's false. The inverse of P implies Q is keeping the same order as the original statement, but then putting nots in both of them. And so the not P implies not Q is the inverse, and again, we saw in the last section that that is not necessarily true. And so if it's not necessarily true, it's false. And so those are not equivalent to the original, like the contrapositive is. The negation of P implies Q is P and not Q from the last couple slides that we looked at. And so if you ever are asked to find the negation of a conditional statement, you can just create that statement, P and not Q, find the truth table of, you don't even need to try to find the truth table because we already showed the truth table of that is the negation of it. And so if you're ever asked to negate a P implies Q, a conditional statement, you just come up with the statement P and not Q in the English, and that will be the negation of that statement, the original conditional statement. So we're just going to add this on to section 3.5, and based on these two sections now, the next homework assignment includes both of these together. 3.5 and 3. There's a few questions from 3.6 thrown into the 3.5 assignment, and so they're all one assignment together in my math lab. So go there now and work on that assignment.